Hello and welcome back, and that's right, today I want to talk about SSD NAS systems and to address something that we talk about quite a lot on the channel, and that is that all of these solutions on the table here, all of them support M.2 NVMe SSDs inside. Some as low as 2 or 3, some going all the way up to 6 and more bays. This one, for example, the TerraMaster's got 8 of them on board. However, a lot of these systems only arrive with 2.5 gigabit Ethernet on the rear there. And I often see in the comments a lot of users highlighting, why on earth would anyone buy a system like these that runs on super fast SSDs that can put out as little as a gigabyte per second, going all the way up to 3, 4, 5, 6, 7 gigabytes per second, yet have a system that caps it at 2.5 GBE. So what I'm going to do is go through a bunch of different user case scenarios where a system like this that has a whole pile of SSD slots inside but only 2.5 GBE on the rear can be hugely beneficial. First up, let's get the most obvious one out of the way. Containerization and virtualization are those of you that want to run individual applications or whole-scale OS level virtual machines all remotely from a NAS system, 1, 2 or many, and then be able to access them via a multitude of users. Virtual machines, most of the work is done inside, and ultimately accessing a virtual machine remotely relies on 2 main factors: a fairly steady internet or network connection, around about or give or take gigabit is absolutely fine, but on top of that, having great latency, and by great latency I mean very, very low latency, so that the person accessing the virtual machine, when they do click on something on the desktop, that it responds near enough immediately. And when it comes to running containerization, Docker and such, or running the whole-scale virtualization, regardless of whether you're using a full operating system or individual apps, that latency, the M.2 NVMe's, the performance numbers really does benefit you. And in those scenarios, unless you are talking much, much wider spread access, you're not going to need greater than 2.5 gigabit Ethernet there on the majority of these systems. Next up, and this is a fairly recent introduction, and by recent I mean the last couple of years, the utilization of AI in NAS systems and running larger LLM databases and systems directly from a NAS. Now, fair play, it does require some decent CPU and memory as well, but once you've done that, much like the point I made about containerization of virtual machines, the external network connection, given all of the data that this particular AI model or language model or whatever you want to call it, DeepSeek, your chat, GPT, whatever, is running from, is all in system. The external network connectivity becomes way, way, way less important. Obviously, the exchange and the number of recall requests externally can start to hamper things down, particularly if you're going to be running an AI system that is based on creation. So again, whether you're creating images or video, that kind of stuff, that's going to be slightly different. But when it comes to in-system AI managed databases, systems like these, particularly ones like this one, the GEM10 from Ustal, which has a phenomenal AMD compact CPU inside. This only has 2.5 GBE, but it has 3 Gen 4 M.2 NVMe slots inside, which allow for, in a RAID and the right software, some phenomenal AI performance without any concerns about external network connectivity. Audio production and high quality audio streaming. We talk a lot about video media more than anything else when it comes to streaming here on the channel, but I'll say right now, when it comes to the production of audio, the management of audio, particularly high bitrate audio, SSDs are essential. When it comes to the playback of quite dense media, it has to be said that you are, when streaming, combating the main factor of buffering. When you are accessing an audio file, you need to make sure that the buffering and the laying down of that track, by the track I mean in a railway sense, laying down that track is happening faster than organic playback. And that's another area where our friend Latency comes into bear. And SSD-based optimized systems like these, again, the priority of the external connection is far, far, far less important than the internal performance of the SSD media, because you aren't accessing the whole file at once. You are accessing it in segments in many cases. And again, when we talk about particularly dense media, FLAC files there, this is when high performance, low latency media becomes the buzzword. This is another one that's relatively recent, and that is surveillance optimization on these systems. Now, you're obviously going to be tacked in quite heavily by the surveillance software that you're using, and that can run on the system. But with a lot of modern software appliances around surveillance supporting AI-assisted deep video analysis, this is where mechanical hard drives, I should say, are just not cutting the mustard. And having storage media that can allow AI-assisted surveillance tools to access existing databases for things like license plates, for facial recognition and more is hugely beneficial when you look at SSD media. Now, obviously, in those scenarios, most users are not going to be archiving days, weeks, months or years of surveillance footage on an SSD. It does aid for retrieval when it comes to recognizing some of the notifications assisted by AI, but I would say that there is still an argument for an area of SSD storage, which you can get in some systems like these ones, where there is an area of SSD storage alongside a larger hard drive, or you can go ahead and have a secondary tiered slower system using hard drives, but the main surveillance system that's going to be archiving up to the minute warm and hot surveillance data for AI recognition. That's where your SSDs will be beneficial. And once again, the output on these systems doesn't need to be greater than 1 gig or 2.5 gig, even in surveillance cameras, and you can adjust the bit rate anyway. Next up, one that is overlooked quite a lot, and indeed I don't talk about that much on the channel, game servers. A lot of people like to run their own custom game server. Again, we can look at basic stuff like Minecraft, but it goes much beyond that. And a lot of modern PC titles allow you to host your own server. And in those scenarios, what you want for the main game-based assets, and particularly for modded servers, is to run a lot of that off of faster SSDs. But once again, the bandwidth afforded isn't too problematic in terms of the external connectivity, because most of the time the real limitation comes down to the internet service provider and upload-download of where the server is being deployed. The actual connection between the NAS and that internet connection in the original local area network before it's remotely accessed, it becomes largely redundant, and therefore having a NAS system like these that you use, a containerized application to very, very quickly set up in Docker or something your game server of choice, having it running on SSDs, again, performance, low latency is hugely beneficial to keep those pings down, or at least control as much as you can from your side. And introducing a 10, 20, 50, 100 gig connection between the NAS and the local area network once again becomes redundant if your internet connection is barely gigabit to start with. Digital forensics and cybersecurity engineers. Last year I went to a Synology exhibition, and while they were there, they had people in from the British Met Police talking about when they were going through cybersecurity and retrieving data from old systems. Now, when you do that, whether it is for evidence in pre-existing cases or just to analyse digital equipment that has been ascertained on scene, a lot of the time those digital assets can't live in multiple locations. Those backups need to be signed in and out quite securely, and also access to that data needs to be heavily authorized. Now, in those scenarios, a lot of the time you need the media living inside a NAS solution, probably a great deal more polished and professional than some of the more domestic and prosumer enthusiast solutions here on the table. But nonetheless, in those scenarios, they're on a very tight local area network, and more often than not, they are not dealing with large file assets that need to be gathered and accessed all the time. Sometimes they do, but they're not going to be editing those files. What they need is all of this data to be accessible from a single location, presumably with backups in place, securely kept, but that data being accessed with as lower latency as possible. That could mean whether it's the local area network or being accessed remotely via a secure connection, you want the data to be presented, accessible, and the metadata and the very small elements of data from that the background, the metadata of that being accessible and presented as quickly as possible. And in those scenarios, systems like these, or larger scale ones realistically, the focus needs to be on the storage media presenting that data as quickly as possible, not just how quickly it can output via the external network connection. Because in that scenario, if anything, when it comes to images, when it comes to audio files, that is pretty much overkill. It's about the inside storage media delivering and presenting data as quickly as possible. And the last one, another slightly obvious one some might say, and that is those that want to run a website or an email server from their NAS. For those users, an external network connectivity at 2.5 GBE or a couple of individual ports there, that's already more than the network bandwidth they are going to need, because they're going to be throttled by the internet service provider once again. Most of the time you are going to be lucky if you're anywhere in the world that has a greater than gigabit internet speed. So this device here, for example, once again coming back to the U-Star Gem10, that has a potential 5 gigabit via link aggregation or SMB multi-channel, is going to be so much network bandwidth on its own before you start running an email server or running your website. Again, having SSDs inside for running that kind of thing, particularly if it is a more complex website that has databases that, take information and then correlate quotations and stuff like that, and that is doubly so for those that have got email servers where they may want to retrieve older attachments. Those kind of users, and particularly those smaller businesses that don't really want to go into a larger rack mount solution, desktop SSD flash solutions are going to be hugely beneficial. And once again, even if this seems a little bit too overkill for you, you still have hybrid storage solutions that give you the ability to use traditional hard drive storage alongside M.2 NVMe SSDs. Now, it's worth highlighting here at the end of the video that just because you did buy one of these solutions, here's one that we reviewed a week or so ago. This is the GMT Tech G9. This is a 4-bay M.2 NVMe that's got a couple of 2.5 gigs there on the back, and it's about 160 to 180 Nika. You might be thinking down the road that you do want to upgrade this beyond 2.5 GBE. Well, notwithstanding the fact that there are USB adapters that allow you to add 2.5 gig and 5 gigabit Ethernet and Wi-Fi 7 to USB adapters that you can use. Previously on the channel, we've discussed that you can convert one of those M.2 NVMe's into a 10 gig Ethernet port. You can choose to add it to an OCuLink port, which allows for even greater network connectivity. And of course, you have M.2 to PCIe upgrades there. The sky's the limit really when it comes to an M.2 NVMe system. I say the sky's the limit, realistically the software you choose to use is the real limit there. If you are going to go for an M.2 NVMe SSD optimized solution, keep in mind that not all CPUs are built equally. And just because you are getting a system with some high performance M.2 NVMe SSDs inside, the CPU inside might be a little efficient. I'm looking at you N5105, I'm looking at you N100, but on top of that, the lane allocation is worth keeping in mind. That just because this, for example, is a Gen 4x4 SSD, so this in theory should give me 7 gigabytes per second performance. Realistically, if I put this inside this, which has 3x1 generation speeds on each SSD, it's going to cap it at around 800 megabytes per second to shy of a gigabyte. So do keep that in mind. But this has been who the hell M.2 NVMe SSD optimized systems are actually for when their external network connections seem pretty rubbish. I hope you found this video helpful. Link below are a few different solutions that I've highlighted throughout the course of this video, as well as other guides and reviews we've done on these systems. If you've got any other questions or perhaps other points that I've missed, use the comments below to let me know. But apart from that, thank you so much for watching, and I'll see you next time.